Decarbonizing Indonesia's new capital city, retrofitting the design of ministries complex in the IKN with closed-loop system of carbon capture and microalgae secondary skin. Indonesia has finalized the agreement to shift its capital city to East Kalimantan, a move that will result in substantial carbon release. Comparing this to DKI Jakarta, Indonesia's current capital, emits 206 million tons of carbon annually. When extrapolated into individual contributions, the anticipated stated residents in the IKN area will generate about stated number of carbon. With a projected of 1.6 million people by 2024, the carbon emission will multiply by 11-fold. Despite varied reforestation efforts planned by the IKN regional government, including reforestation, renewable energy adoption, and energy conservation, these measures might not suffice to counter the alarming rate of carbon emissions. Implications that the authors found was in the design of coordinating ministry complex building, where low E-glass material will be used extensively, which requires assessment. Authors proposed an exterior wall of microalgae resembling vegetation, absorbing carbon and yielding valuable products such as algae goods and renewable energy biomass. Literature review on microalgae and photobioreactor. Here are the characteristics of microalgae, where as long as there is sunlight, microalgae can photosynthesize and grow both in saltwater, brackish, and freshwater. Microalgae is in abundance to the side of IKN, located only 100 kilometers away from the zero point of IKN Muara Badak waters. Photobioreactor characteristics. Photobioreactor refers to the process of utilizing sunlight to convert organic materials into biomass. The application of algal photobioreactor is the panel-type photobioreactor, where the effective use of land such that it can be integrated with the facade. The length of the panel can vary according to the desired volume and surface area. However, the depth should be constant as it relates to light penetration. Light is a major factor for microalgae growth in photobioreactors and should be given special emphasis in the design of PBR facades. Solar trackers with automatic control units can be used for tilt angle adjustment. Sprinkles are used to cool down the PBR volume. In Indonesia, Martokusumo et al. Explored microalgae facades for ITB Innovation Park in Bandung in 2017. Literature review on direct air capture. Direct air capture technology extracts carbon dioxide from the air to create various products like carbon neutral fuels and food, aiding in achieving net zero emissions. Two DAC methods are employed, solid DAC and liquid DAC. Solid DAC we will be using involves a solid sorbent materials that operates through a cycle of adsorption and desorption. Climeworks, a Swiss company, is a pioneer in solid type DAC products. Their unique DAC process utilizes 80 to 120 Celsius of heat, often available from building exhaust, to fulfill most energy needs. Here is the framework of our research. Analysis and discussion from IKN's current plan. Implementing low emissivity glass on 10 of its buildings offers advantages. Low E glass serves as solar control, shielding indoor spaces by reflecting excess solar heat. This preserves natural sunlight access, promoting natural lighting indoors. Discussion on cutting carbon emissions, including with low E glass, a UK case study in a four-season climate, mirroring Indonesia's warm, humid conditions, especially during the summer. The graph on the slide shows the carbon emission comparison between different types of glass in the UK. Discussion on cooling load assessment. Assuming a common VRV is used and emitting stated number of CO2 per 1 million BTU over 20 years, the BTU load per floor is stated as such, and each floor will produce stated number of CO2 for air conditioning or stated number of CO2 per building. And so we can compare the carbon reduction from air conditioning by low E-glass and carbon reduction from air conditioning by direct air capture. The use of low E-glass will reduce carbon emissions by stated number of CO2 per 20 years or stated number of tons of CO2 per year, reducing carbon emissions by 4.1% to 5.3%. To capture 1 million tons of CO2, the DAC system will require 0.4 to 66 kilometers square of land. Its application to IKN, the calculations are stated in the slide, and the buildings have the potential to reduce carbon from stated number to stated number of CO2. Availability of microalgae in East Kalimantan. Bora water study found diatoms as the dominant microalgae. Results also connected microalgae prevalence with chlorophyll A levels in Kalimantan Bora waters, as highlighted by Aryawati and Toha in 2011. This supports the suitability of microalgae solutions aligning with local resources. Microalgae facade design concept, studying the movement of the sun. Studying the movement of the sun is essential due to the challenge of accurately assessing light intensity on outdoor PBR panels. Global radiation is used as a variable for a comparative study with an existing implementation of PBR in Munich, Germany. The calculations are stated on the slide. A conceptual diagram of how the DAC and PBR technology will be implemented in a closed-loop system. These are the steps to the process. First, DAC system captures CO2 from air and transported to microalgae PBR panels via CO2 pipeline. Second, nutrients, sunlight, and CO2 enter microalgae PBR panels, generating heat, microalgae, used water, oxygen, and biomass. Third, generated heat will be redirected into the DAC system. Fourth, the produced oxygen is released into the surrounding air. Fifth, biomass can be processed to become electricity, which, according to ICAN plant, can be channeled back to JPCI ICAN Smart Power Grid so that it is stored for shared use by the city. Microalgae is harvested every 3 months for conversion into medicine, food, and cosmetics. Sixth, microalgae growing media's used water can serve buildings' needs like watering vegetation or firefighting, nutrition separator, and enables the extraction of nutrients for PBR requirements. Microalgae facade design concept, dimension calculation. The dimension for the panels are calculated using different variables for the building. PBR panel modeling. Utilizing the data gathered for additional building envelope design in the ICAN region, a modeling approach is proposed for implementing the process data. Inevitably, the integration of these technologies will still have embodied carbon. The first one is from the AC transportation. Using the cargo transportation from the port of Zurich, assuming the volume of the DAC and the requirement of 18 units, the carbon produced by the DAC transportation will be as number stated. And the second one is from the construction and the operational of PBR, which are calculated through its materials and operationals. The photobioreactor will embody stated number of CO2. And the total of embodied carbon is as the number stated, and the direct air capture amounts to 4,000 tons of CO2 per year, and the carbon debt should be paid off in less than a year. To the conclusion of the paper, number 1, the capital city relocation to ICAN involves significant carbon expenditure, while ICAN aims for sustainability, architectural innovation is lacking. Number 2, East Kalimantan's abundant microalgae holds potential as a breakthrough material, proposing DAC and PBR integration for carbon reduction and energy generation. Number 3, feasibility was tested by comparing pre- and post-technology carbon reduction. After application, the building could actively cut almost 6,000 tons of CO2, generating oxygen, renewable heat, biogas, and biomass. Number 4, comparative embodied carbon analysis of microalgae and DAC integration suggests a depth of stated number of CO2 offset by absorbing 4,000 tons of CO2 annually. In conclusion, this innovation offers multiple benefits and is a viable application. And here are the references for the paper.